All right, let's take a look at letter B. Again, starting with our formula, B equals P plus PRT. My principal, I don't know, but I do know the balance, so we'll start from left to right. 1,424.50. I'm going to knock off that 0 because it doesn't really do anything but take up space. My p's have to stay as variables because we don't know what they are. My rate is 0.035 because I turned that into a decimal, so 2 places. And my time is 6 months, so I have to put that in as 0.5 because it's only half of a year. So we don't want to put in 0.6. Remember, 0.6 is 6 months out of 12 months, which is 1/2, or 0.5. All right, so now we need to start solving. We have 2 p's though. So before we get a little overwhelmed, the first thing we can do to make things a little bit easier is to multiply 0.035 times 0.5. When I do that, I get 0.0175p. So I just put this p at the end, and I'll rewrite everything else that we have on that line. So it's p plus all of this. Okay, so what I did is I combined this times this and got this, and these are all multiplied together, so it doesn't matter what order I write them in. I just decided to put the p at the end, which is how it should be written, because we have like a variable with a coefficient, the coefficient always goes first. That's really what this number here is. This is a coefficient. Okay, so now we want to say, all right, we need to get our p's together. This p actually has a coefficient of 1. So this is 1p plus 0.0175p. So my 2 coefficients I can add together to get 1.0175. Okay, and hopefully this isn't confusing, but if it is, just think about it as though this wasn't such a decimal. If this was just 4p and that was 1p, you'd add them together to get 5p. So here we add 1 plus 0.0175 to get 1.0175p. And we're just about done. Now that we see this, this just needs divide. These are being multiplied, so the inverse is to divide. Divide. They cancel out. P comes down. 1424.5 divided by 1.0175. I get 1,400. I look to see if it makes sense. Is it logical that my principal is $1,400 when my balance is $1,424.50? Yes. Obviously my principal has to be less. We did a great job. All right, now that was all simple interest, which means your interest, the extra money you have, is based on whatever you start with, only your principal. So each year it keeps adding on based on what you put into your account, your principal. Compound interest is when, there we go, when an account earns interest compounded annually. The balance is given by this formula. B equals P times 1 plus R to the T, where T is an exponent. Okay, so same variables mean the same things. B is balance, P is principal, R is rate, T is time, but now we have an exponent here. And what this means is, let's say the first year you put $500 in. Now interest is earned on that, and now you have $550. Now with compound interest, interest is earned on this amount now, and so maybe you'll have like $610. And then interest is earned on that, and maybe you'll have $675 now. So it starts growing exponentially, which is why you have this here. So let's try a problem, and your calculator will be very helpful with solving these problems. We only have 2 left. Compound interest. You deposit $1,500 into an account that earns a 2.5% interest compounded annually. So that's the formula we're going to use here. Find the balance after 6 years. Okay, so compounded, even though it says balance, we're talking about compounded. That's important. So it's B equals P times 1 plus R raised to the T. We want to make sure we go ahead and label our variables. Balance, we don't know. We do know principal is $1,500. Rate is 2.4%, which is 0.024. And time is 6 years. So I can substitute them in. 1,500 times 1 plus my rate is 0.024, and my time is 6. as an exponent. Now you have an option. If you want, you can type this whole thing into your calculator straight. Just do 1500 parentheses 1 plus 0.024. And then your calculator for exponents is probably going to be a caret, a button that looks like that. You could also do it in steps, simplifying. You could just add this together. 1, so you get 1.024 when we add them. Next order of operations step is going to be to do 1.024 raised to the 6th power. And that's going to give you most likely a very long decimal, so you can round it to 2 decimal places. 1500, 1.15, and then just multiply those together. And my final answer comes to a balance of 1729.38. If I would have just typed this whole thing in straight across, 1500 times 1 plus 0.024 raised to the 6th power, I would get the same thing, no rounding errors in this problem. So there we go. We only go 2 decimal places because we're talking about money. So my balance here, I started with 1500, now I have 1729.38. And the next year, it's going to build off of whatever this amount is, not whatever I started with. And that's the nice thing about being compounded. If you're putting it into a bank, that's really good. So let's try one just like this. Again, your calculator is going to be very helpful. You deposit $1,200 into an account that earns 3.8% interest compounded annually. Find the balance after 5 years. So we're doing compounded, so B equals P times 1 plus R raised to the T. Again, I'll give you those formulas. And we are ready to fill in our blanks. Principal, $1,200. Rate, 3.8%, which is 0.038. In time is 5 years. We're trying to solve for the balance. So 1,200 times 1 plus 0.038 times 5. So I'm going to go ahead on this one. I'm just going to multiply straight across. The calculators that we have at school will allow you to just type in everything across on your calculator on your screen. The way I did it above is if you don't have the scientific calculators we're using at school and you're using one that's more basic, then you'll want to follow order of operations on your own. But for our purposes, just type all of this in, multiply it together, have your calculator do the work, and $1,445.99, which ends up rounding it up to $1,446 would be your answer there. Okay? So the important thing here is that we understand the difference between simple and compounded. Simple only builds on the interest each year. It keeps growing only off of. So if you add $50 each year in interest, you're going to keep adding $50 every year no matter what. Compounded, because it's this exponential, next year you might add $60. The year after that, maybe $75. Then after that, maybe $90. And it's just going to keep growing because it builds it off of the prior balance. So this is a lot of information here, but watch it again if you need to. It's very important, very useful stuff. And 2 more comments. For these problems, they're going to give you the we haven't solved equations where you're solving for the exponents yet, so you should be set. It won't be as complicated as the ones we did on the other side where you had to do some equation work. It'll be mainly, do you recognize the formula for our purpose right now? And secondly, everything we've looked at here has been good interest, where you put it into an account and you make money. We noted in the vocabulary, though, that sometimes there's bad interest, and that has to do whenever you're using a credit card, for example, or if you have student loans and you're paying money. So the companies charge you interest, and usually those interest rates are pretty high. So this, again, just keep your ears peeled, watch TV, you'll see interest and percent rates showing up all the time on cars and stuff, and now you know a little bit more. Great job, guys.